Hi, this is Kelly Hill, technology reporter with RCR Wireless News. I'm joined today by Bryan Helmick, who is product manager with test company Rohde and Schwarz North America. How are you today, Bryan?
I'm good. How are
Good. We
you?
are going to be talking about LTE device testing. Um, and I wanted to start off by asking you, what are some of the underlying business drivers for bringing LTE devices to market today?
Uh, Really, you can break it down to three different drivers. I would say time to market is probably the number one most important thing. Reason being, if a device gets to market or gets to the carrier even a week or a month or a couple months after plan, and if an operator gets a device with those features a week, a month, a couple months after a competitor, it can mean hundreds of millions of dollars. So it can mean the difference between selling 100,000 of a device or quantity million of a device. So this is number one. Cost. Cost is key because there's always going to be a limit to what consumers will pay for a device, and in turn there's going to be a limit to what operators will pay for those devices from the device manufacturers. And last, quality. The quality of device is very important, especially with the increased cost of these devices. Quality becomes really important. If a device is not working for a consumer, they will take it back to the store. And when they take it back to the store, someone's going to eat the cost of that device. So it will end up going to a service repair depot. This device, if there's no fault found, most of the cost goes to the carrier. And if there is a problem, then the device manufacturers eat that cost. So there's a lot at stake.
Okay. So let's talk about the ecosystem that is involved with LTE devices. There's a lot of different players that come into the game at different points in the development, pre-launch of a device, and also up to launch. So can you kind of give us Rohde's perspective on what the lay of the land looks like in terms of the device ecosystem?
Definitely. Device manufacturers, they have to go through a lot. Actually, there's a lot of players in bringing a device to market. The first one I would start with would be standards and certification organizations, certification bodies. That's people like 3GPP, 3GPP2, CCF, GCF, PTCRB. They're the ones that define the technologies themselves and the test cases that a device manufacturer, chipset manufacturer, test lab need to run in order to make sure a device works. There's chipset manufacturers, of course. I won't name them all, but there's some pretty dominant ones, and these chipset manufacturers, they need to support the features that the carriers want, and they need to do it as early as possible. It's a pretty competitive market. Device manufacturers, of course, so everybody that you see in the stores. You've got the carriers, so the Verizons, AT&Ts, the Sprints, the T-Mobiles, the changing landscape there around the world. You've got the test houses, so the third-party test labs, the test houses that are running the tests for carriers or PTCRB, GCF. You've got infrastructure manufacturers, so everyone involved in building that network, all the equipment, so the eNode Bs and all the core network parts. So you have those players, and you've got the service repair depots. Like we talked about before, devices go back, someone's got to test them and repair them.
Okay. So given that that large ecosystem, who would you say drives chipset and device design? Is it carriers because they kind of have the final say? Is it device manufacturers who are really kind of on the cutting edge of the development? What do you think?
Yeah, ultimately, the carrier, the operator, is the one that's going to be pushing the technology. The carrier is the one that everybody needs to make happy because they're the ones that are driving the consumers to their networks to buy devices. And a chipset manufacturer might support a technology earlier or some extra technologies that may never be used by any carrier, just for competitive reasons, because they want to be ready in case a carrier decides to, for instance, deploy 3-carrier carrier aggregation, or EMBMS, or 4-carrier carrier aggregation, some new technology that doesn't exist yet, that may or may not be deployed. The chipset manufacturer might do it, but the operator, at the end of the day, everybody needs to support what they want. They're the ones that write the requirements. They're the ones that enforce the requirements. They're the ones that are driving all the testing, and what they say goes.
Okay. It's interesting. While I was working on the special report that's related to LTE device testing, I was talking with Sprint, and they were telling me that it's more of a partnership than it used to be. That when timelines come up for devices, it's far more likely to be a situation where they work with each other. So it's interesting to see how the device manufacturer role has changed over time.
Yeah, and these days there's so many technologies changing so fast and being added so fast. So many test cases, test plans, test requirements being added and changing so fast. It's pretty incredible. One of the big areas right now is IMS, VoLTE. There's a big push to get VoLTE on practically every carrier network, and because of this, there's a lot of test requirements, and there's a lot of testing going on, field testing, lab testing, a lot of attention being put on this, along with anything to do with IMS, so SMS over IMS, all the VoLTE audio quality, VoLTE video quality, because VoLTE is not just audio. Voice over LTE is actually voice and video over LTE. There's rich communication services, which is sort of like supplementary services, being able to do a conference call over video with your phone. And there's a lot of different things, but it's these supplementary applications that right now a lot of people use over-the-top applications for. There's carrier aggregations, or aggregating multiple carriers to get higher throughputs on the downlink, and even eventually on the uplink. You've got EMBMS. EMBMS is going to be, I think, a big technology for carriers. Verizon already made it public that they are going to be deploying this, and this will be broadcasting video, broadcasting movies, NFL, different content to devices to everyone on one channel. So it's not a peer-to-peer thing anymore. This is to everyone, which is quite efficient. There's all types of new location-based services technologies for location determination, so not just using satellites anymore. In fact, not just using GPS satellites anymore, using GPS, using GLONASS, so the Russian satellites, eventually going to use Chinese satellites, we do, using the LTE signals for location determination, using Wi-Fi, and then combining all that to make for very accurate positioning. It's pretty impressive, pretty exciting, and that's just a few of the technologies being deployed. There's a lot more. So
a lot of complexity. A lot of complexity going on right now. So with all of that complexity in mind, can you kind of give us a sense of what are the major milestones and the timeline that's involved when it comes to designing, testing, and launching devices? That's a lot to put in a single device, a lot of capabilities.
Yeah, okay, so milestones. It's hard to really give a number on how long it takes. I mean, the timeline, it will be different per device, but they have to go through a lot. There's GCF, PDCRB testing. So, well, let me start actually with the UE design. The design process is pretty incredible from start to finish. I think a lot of UE manufacturers actually work with the chipset manufacturers in these design requirements to make sure that they can get everything they need in the chipset so that their device will be more competitive for the carrier. And this design process takes a long time, takes a lot of planning, and even when the device is not quite ready, they'll start doing a lot of their final testing. So sort of do things in parallel. And a lot of the different stages that they're doing in parallel would be like GCF, PTCRB testing. That's things like RF, RM, protocol conformance, doing location-based services testing, so minimum performance tests, protocol conformance tests, for all technologies that a device supports. There's carrier acceptance testing, which is really a huge animal. This is something for some carriers that is much, much bigger than conformance. It's much more complicated. There's more test cases, much more stringent than even GCF and PTCRB requirements. Not every carrier has these. Some carriers just rely on conformance, but in North America, there's quite a few that have their own test requirements, and it covers RF, RM, performance, things like data throughput, handover reliability. I mean, you name it, it's in their test plans. There's OTA radiated performance, so that's like antenna performance testing, TIS and TRP. There's IoT, so doing IoT, which is sort of the term that is used for UE manufacturers going into infrastructure. An infrastructure manufacturer like, I guess Ericsson would be one that you're familiar with, and they'll have a lab, and you'll go to that lab and you'll make sure that the device and the infrastructure work well together, and they run through a test plan there. Field testing is quite huge. I mean, ultimately, you got to get to the field, got to see if these devices will work with the infrastructure. And service and repair. Service and repair is thought of very early because a service repair depot is almost like a manufacturing facility. They got to get through a lot of devices, so these devices have to be integrated into the whole process to make sure they can run tests very fast. RF tests, very, very fast. And yeah, I would say those are the main milestones for getting a device through to market.
Okay. So then how does LTE factor into this as a major evolution? You know, how is LTE redefining how carriers you know, talk about launch, how they think about subsidies, you know, how they look at their repair process?
Yeah, LTE, well, with LTE, there's a lot of other technologies that come with it. So LTE brought the need to also support legacy technologies and interrat. LTE increases performance. It's fantastic, but it also increases complexity. The number of technologies is seriously mind-boggling. You have antennas for GPS, GLONASS, LTE, Wi-Fi, Bluetooth. I mean, it's absolutely incredible how much is there. It's really incredible. And the brain behind these devices, the software controlling them, is quite complex. So with this comes cost. And the cost of the devices, it cannot go up too much, but it still does go up. Then you have customer expectation. These days, people don't like to have their phone for 5 years. I mean, the majority of consumers want a new device as soon as there's a new feature. They want the latest and greatest. And that leads to increasing turnover. So with the increasing turnover, the increased cost, service and repair is becoming a big, big part of, it already was, but now it's even a bigger part of this whole ecosystem, this whole process that a carrier has to deal with. If a carrier, like I mentioned before, if a carrier gets a device and there's no fault found, then they'll eat the cost. If a carrier gets a device and there's an issue with the device, then typically it's the device manufacturer that will eat the cost. So this is really an important part of the process for devices, and LTE's made it more important than ever.
Okay. All right, so we've covered a lot of ground here, and I'm wondering if you can kind of recap for us, you know, what does it take to successfully bring an LTE device to market?
Yeah, well, number one, you got to get through all the major milestones, so the conformance, IoT, all the different milestones, the major milestones of getting a device to market. You got to do that as fast as possible. You need to prepare. You've got to prepare to get through GCF, to get through carrier acceptance, to get through your OTA, to get through all these stages. You need to do it as fast as possible. And test equipment is critical in this process because you need to prepare. And you can't always go out to the field or find a network, test network, to run tests on. You need to have an emulator in your lab to do this testing. So that's number one. Time to market of new features, advanced features like 3-carrier aggregation, all this VoLTE, these new RCS supplementary services, video conferencing. All these new features need to be tested as quick as possible. You can't do that on a test network. You get access to these features first with test equipment. So the ability to meet time to market for these features, you got to get it on test equipment, and keeping test costs down. This is a big one. No longer can labs with all these technologies, all these applications that need to be tested, no longer can labs have one box for every single thing. They just can't. It doesn't make financial sense. So it is important to have a platform, a test platform, that covers multiple technologies, GSM, WCDMA, LTE, covers location-based services, Wi-Fi, Bluetooth, does everything in one box, Interrat, etc. Covers all the applications, so conformance, performance, carrier acceptance, lots of different things, protocol, RF, RRM, in one platform, and it's upgradable. You can upgrade the box, you can buy it for one thing, and upgrade it to do anything in the future. These are extremely important. Lastly, to keep the costs down, you can't hire 500 people to run your test cases. There's a lot of expertise needed to cover all those technologies and all those applications. In order to do that, you cannot have one person in the lab that just knows everything. You need a team, but you can't hire a team. You can't just hire a team to use every box. So you also need a company, a partner, not just a company to buy a box from for testing, but you need a company that can act as a consultant, like a technology partner. And these are all critical for bringing an LTE device to market and doing it quickly, keeping the costs down, and keeping the quality up.
Okay, great. Bryan Helmick, product manager with Rohde and Schwarz, North America. Bryan, thanks so much for your time today.
All right, thank you.